Okay, so this is the review for the Chapter 5 test. So bear in mind, some of the questions on the test are going to be in a non-graphing calculator or any calculator portion of the test. So some of the questions that we're going to do here, you will not have access to your graphing calculator. So I'm going to show you how we're doing these problems without that graphing calculator. Okay? So in the first problem, so in this whole box, we are simplifying, and when we get towards the bottom, we'll be solving. And you will be expected to show your work. So the idea is, what is 27 to the negative 1/3 power? So I don't know what 27 to the negative 1/3 power is. What I do know is that a negative exponent moves it down first, and that a 1/3 power is the same as a cube root. And then as part of our extra credit quiz, you were expected to know that the cubed root of 27 is 3. So when you're done, this is 1/3. Okay? The next problem, how do you simplify this? The rule is that there is no radical in the denominator. So when you have a problem like this, you're going to multiply it. We called it by the conjugate. And that means I'm going to multiply it by 1 plus the square root of 5. And I'll do the same to the top, because that just means I'm taking this fraction and multiplying it by 1. So for the top, I'm going to distribute the 2. And 2 to 1 is 2, and 2 times the square root of 5. They aren't similar enough to multiply them, so I'm just going to write it as 2 times the square root of 5. And then in the bottom, we talked about that this thing, the conjugate, works because if you have FOIL, first, outside, inside, last, that you actually just need to do the F and the L. We called it full. So I'm just going to multiply 1 and 1 for 1, and then the negative square root with that. So the minus is going to come along, and the square root of 5 and the square root of 5 multiplied is the square root of 25, which just changes to a 5. So when I'm done, my numerator will stay the same, but then I can take 1 minus 5 and get negative 4. And this is a great answer. If you notice that simplifying triangle that we talked about, that you can take a 2 out of those, that would be great. I can divide this by 2, I can divide this by 2, and I can divide this by 2. So this is the better answer, okay? But this one will be accepted on the test. All right, the next problem, we're simplifying, and one of the rules is you can't have anything perfect under there. So I've went ahead and made the factor tree for 32. And this is where we talked about you can make the perfect, there's a little 2 here, and the not perfect. So here's my perfect, here's my not perfect. So of these 5 2's, 4 of them are perfect and 1's not. I don't have enough x's to be perfect. Of the 9 y's, 8 are perfect and 1 is not, and all my z's are perfect. And what makes them perfect is that 2 goes into their exponent perfectly. There's no remainder. So the 2 and the y and the z will come out, and I just use division to get their exponents. 2 goes into 4 2 times, 2 goes into these 8's 4 times, and then it would be better to turn the 2 squared into a 4. And then here's the rest. And then all of this stuff will just stay in there. So when I'm done, here is my answer. Okay? So 64, again, the idea of 64 is it's not number 64. This problem is I don't know what 64 to the 5/3 power is, so I'm going to rewrite it. And when you rewrite it, the denominator becomes the index number. So the cubed root of 64 is 4. And then you might need a calculator for this, but otherwise you're taking 4 to the 5th power. And this should be a problem on the test that you don't need a calculator, but 4 to the 5th power is 1024. Okay? But on the test, I'm looking for this work to be shown in this work. I don't want just 1/3 or even the decimal, and I don't want this. I want the work that gets you there. All right, adding, subtracting, very picky rules. You need to find something common to add or subtract, and right now these don't. So the idea is I'm going to try to simplify these radicals so that I can subtract them when I'm done. So the 5 and radical 3, I'm going to leave alone because 3 is prime. You can't factor that down anymore. But 12, and because this is a square root, I'm just going to break it into the square root of 4 and the square root of 3. I don't think I need to make the factor tree for this one. Square roots are a little bit easier to work with than some of the other roots. So the square root of 4 can become a 2. And now I'm ready to subtract because there's something common between the two that I can subtract. So when I'm done, I have 3 of these square roots of 3. And the same thing's going to happen here. I'm going to try to simplify the radicals so that I can make them so that they are subtractable. So 5 you can't simplify anymore. It's prime, so it's going to stay the way it is. And because this is a square root, and it will just be a square root on the test, I'm going to break it down into the square root of 9 and the square root of 5. So this one stays the way it is. And now this becomes a 3 with the square root of 5. So when I'm done, I have 2 of these square roots of 5. Oops, you can't see that. All right, moving on. So this problem, first, I'm going to get this problem to look the way it did in more of our other ones where we broke it up into 2 square roots. But as it turns out, these are both perfect, and I don't need to do any of this stuff that we'll do over here. I can just take the square root of this, it's x. I can take the square root of 25, it's 5, and you're done. All right, and a problem like this, so this problem, I think you're going to see it on the back, is where it becomes such a big problem, we organized it, and the first step is if there were parentheses, which there aren't, I would distribute the parentheses exponent into all the other exponents. Then the second step is I would organize it, I would make houses. So I've got a fraction, so I'm going to make a fraction bar, and I'm just going to go through and put my numbers in a house, so 12 and 2, and I'm going to cross them off. I'm going to put my x's in the house, so they all go where they normally are because there are no exponents or negative exponents. And then I'm going to put the y's in a house. And I've gotten everything. So the idea is instead of one big problem, I have 3 little problems. And 12 divided by 2, don't subtract these, is 6. When I combine these, I have 6 x's. If you notice over here, these y's will just cancel out so that when you're done, hold on, you're going to have a y squared in the bottom. And that's your answer for this problem. All right, so this one, what I'm going to do is make this problem look more like this problem. So the first thing is just multiply them. I'm not going to multiply 27 and 9 because I'm just going to have to break them into factor trees anyway. So, but I can combine the x's into x to the 5th. So what I'm going to do instead is, and again, you can multiply 27 and 9 and then make a factor tree of that, but I'm going to make a factor tree of 27. And a factor tree of 27, as it turns out, turns into 3 3s. And a factor tree of 9 turns into 2 3s. So when I'm done, I can rewrite this as a total of 5 3s and 5 x's. And as it turns out, they're both perfect. And they can both come out, and their exponent, 5 goes into 5. It would just be a 1, which you don't need the 1, but you can put the 1 if you want. All right, this one, that's not numbered. I don't want to say number 3. So first I'm going to make a factor tree for 8. As it turns out, that becomes 2 cubed. Here's the rest. And then I would have the perfect and the not perfect. Sometimes when we do this, we leave out the cubed. Try to bring it through so you remember which one you're working with. So all my 2's are perfect. All my x's are perfect. All my y's are perfect because 3 goes into their exponent perfectly. Now of my z's, 3 are perfect, but 1's not. So this 1 z will stay in, and then the 2, the x, and the y, and the z will all come out, and they'll all have an exponent of 1. 3 goes into 3 one time, except for the 6. 3 goes into 6 2 times. All right, this problem is just like the problem at the top. You can't have that radical in the bottom, but to get rid of this radical, you need, and how we multiplied by the conjugate, I'm going to multiply it by the conjugate. And it just means you're going to multiply it with the same 2 terms, but an addition sign instead. So again, I'll start with the 2. The 2 will distribute to the top. I'll get 6, and I'll get 2 square root of 5. In the bottom, you can multiply this, you know, the 3 visits the neighbors, the radical 5 visits the neighbors, but the conjugate's going to make things cancel out. So again, you can just do f first, so that's 9, and I'm going to have a minus sign because when I multiply the L, a full, so square root of 25, that'll just turn into 5. So when I'm done, I'm going to have 6 plus 2 square root of 5 over 4. This is a great answer if you left it like this, but if you see this triangle that you can take a 2 out of and divide that by 2, you get 3, divide that by 2, you just have the square root of 5, and divide that by 2, and you have 2. So this is the better answer, but that one will be accepted. All right, in this problem, the first step I'm going to do, and I wrote this on a lot of your content checks, or if you talked to me about it, I wrote it down on your content check, is I'm just going to try to simplify. So right now, 18 and 49, I can't simplify, but I am going to separate them out into 2 radicals. The next thing I'm going to do is simplify the x's, so I'm going to have 4 x's on top, and I'll end up having 4 z's on top and 3 z's in the bottom. After I do that, I'm going to make a factor tree of 18 and 49. So 18, when I'm done with factor tree, becomes 2 and 3 squared, along with the stuff that's already there. And 49, when it's a factor tree, becomes 7 squared. So now that I've done that, what I want to do is make the denominator perfect. So I'm going to multiply it with another square root, and there are little 2's here, and I need to fix the denominator so it's perfect. So right now my 7's are perfect, no problem. But I need more z's. I need 1 more z, and that means I'll have to put 1 more z in the top. And then what I would have written on your content check is multiply your numerator and the denominator. So for the denominator, when I multiply it, I'll have 2 7's and 4 z's, and I'm going to put that little 2 that's there. And in the top, I'm just going to bring everything along. So I'll have 2, but I'll put a first power with it. I'll have 3 squared, x to the 4th, and y to the 4th. And now what I want to do is take everything out that's perfect. So this 2 is not perfect. It's going to stay in there. I'm trying to think where I can put my answer. I don't have a lot of room here. There we go. I'm going to put a little sticky note here. So this 2 will stay in there. Okay, let me put it below. The 3 can come out, so here's my fraction bar. The x to the 4th can come out as x squared, and the y to the 4th can come out as y squared. And in the bottom, both of those can come out, 7 and then z squared. And then that's my answer. I can't do any more simplifying out here. So, okay, that is the answer for the bottom right one. All right, moving on to the next page. So what I did is I went ahead and made a factor tree of 64. It turns out it's 2 to the 6th. I'm going to break it up into the perfect, into the not perfect, and all my 2's are perfect. Of my 4 x's, 3 are perfect, 1 is not, and none of my y's are perfect. I don't have enough. So I'll take out the perfect stuff, 2 and x, and their exponents will 2 goes into 6 twice, 3 goes into 3 once. I won't put the 1. And 2 squared is fine, but I would prefer that you actually change it into 4x, and then this stuff will stay inside. All right, a problem like this. So this kind of combines what we were doing on the front a little bit. I have an exponent with parentheses, and I'm just going to distribute this in there first. My steps say deal with your parentheses. So when I take 2 times negative 1/3, I get x to the negative 2/3. And then there's really nothing to organize because there's only one thing, but the negative exponent says just move that to the top. So this is what I'm looking for on an answer here. All right, next problem. Parentheses, lots of multiplying in here with exponents. So this 1/2 is going to go to every power, to the 16, to the 10, and even to the 25's power, which is 1. So I'm going to have 25 to the 1/2 power. And 25 to the 1/2 power, that's like the square root of 25, which is 5. I'm going to have a half of 10, so a is going to have a power of 5 because I'm multiplying, and half of 16 is 8. All right, so now we're going to get into the solving, and just to point out on the directions, when solving, check for extraneous solutions. When we get to the bottom part, this is where I'm going to ask that you check both ways, graphing and algebraically. So these are more solving. When we do these problems, and there's just a blank here on purpose, I'm just going to check algebraically, okay?